What if the most destructive force in the universe could teach us something profound about life itself? Picture a black hole, a cosmic abyss so powerful, not even light can escape its grip. Yet within its terrifying depths lies a hidden order, a dance of energy and entropy that eerily mirrors the delicate balance of our own existence. Today, we're not just exploring the science of black holes, we're uncovering what they reveal about the very nature of being human. Because here's the startling truth: the same laws that govern these celestial monsters also whisper secrets about time, decay, and the fleeting beauty of our mortality. Think about the last time you stared at the night sky, feeling both awe and insignificance under its vastness. That duality, the tension between wonder and fragility, is exactly where black holes meet human experience. Inside a black hole's event horizon, time distorts, matter vanishes, and information seems lost forever. But physicists discovered something revolutionary. Black holes aren't just chaotic voids. They radiate energy, they age, and they even obey thermodynamic laws eerily similar to the processes that shape our lives. The heat-death of the universe, the slow fade of energy into disorder, it's all connected to the way our own bodies and memories dissolve over time. This isn't just theoretical physics, it's a lens to reframe what it means to exist. If a black hole's lifespan can be measured by its entropy, what does that say about our own brief flicker in the cosmos? How does the information paradox, the idea that nothing truly disappears, reflect the legacy we leave behind? Over the next few minutes, we'll unravel these parallels, weaving together cutting-edge astrophysics and timeless philosophical questions. By the end, you won't just see black holes differently. You might just see life differently too. So let's begin where all great mysteries do, at the edge of the unknown where science and soul collide. Black holes are cosmic paradoxes, both destroyers and revealers of nature's deepest laws. That boundary we call the event horizon isn't just a one-way street to oblivion. It's a laboratory for some of the universe's most profound mysteries. Imagine standing at the edge of Niagara Falls, where the roar of cascading water drowns out all sound. The event horizon is like that point of no return, but instead of water, it's space-time itself curving into an inescapable spiral. Yet here's what defies intuition. Even in this realm of extreme destruction, black holes obey strict thermodynamic rules, just like a steaming cup of coffee cooling on your desk. They emit radiation, slowly losing energy over eons in a process called Hawking radiation. This means black holes aren't eternal. They evaporate, fade, and ultimately vanish, much like all things in our universe. Their entropy, a measure of disorder, holds an even stranger clue. A black hole's entropy isn't chaos. It's precisely calculated, proportional to the surface area of its event horizon. This suggests something revolutionary. Information isn't truly lost when matter falls in. It's scrambled, transformed, like a library where every book is shredded yet somehow still contains all its words. This mirrors how our own lives aren't erased by time but rearranged memories fading yet echoing in ways we can't always trace. And then there's temperature. Most of us think of black holes as freezing voids, but they actually possess heat, however faint. This thermal fingerprint blurs the line between the cosmic and the quantum, hinting that even the most hostile environments in existence play by rules that feel oddly familiar. It's as if the universe encoded the same operating manual for black holes and boiling kettles, one scaled to apocalyptic extremes, the other to our daily lives. What makes these properties truly mind-bending is how they force us to confront the illusion of separation. We think of life and death, order and chaos as opposites. But black holes show us their phases in a single continuum, transformations of energy, never created or destroyed, only changing form. When a star collapses into a singularity, it doesn't cease to exist, it becomes something else entirely. That's not so different from how the carbon in your bones was forged in stellar furnaces billions of years ago. You're not just alive despite the universe's indifference, you're alive because of its relentless recycling of energy and matter. So when we say black holes have thermodynamics, we're really saying they're participants in the same cosmic story we are. Their evaporation mirrors our aging. Their entropy mirrors our fading memories. Their event horizons mirror the thresholds we cross in life, points where there's no going back, only transformation. This isn't poetic metaphor, it's the universe revealing that the same laws govern the colossal and the intimate. The question isn't what black holes can teach us about mortality, it's whether we're brave enough to see ourselves in their abyss. Entropy is the silent clock ticking in the background of the universe, a relentless countdown toward disorder that spares nothing, not even black holes. At first glance, the idea that these cosmic behemoths obey the same thermodynamic laws as melting ice cubes seems absurd. But here's the truth: entropy doesn't discriminate. It governs the steam rising from your morning coffee just as fiercely as it dictates the fate of a collapsing star. For black holes, entropy isn't just a property, it's a cosmic signature etched into the very fabric of their existence. The larger the black hole, the greater its entropy, not because it's more chaotic, but because it holds more hidden information, like a vault with countless locked drawers. Now shift perspective to the human scale. Every time you forget a name, every time a wrinkle forms, every time a cell in your body fails to replicate perfectly, that's entropy at work. Our bodies are temporary islands of order in a sea of chaos, fighting a battle they're destined to lose. But this isn't tragedy, it's physics. The same force that stretches a black hole's lifespan across eons also measures the fleeting stability of your DNA. Think of it like sand slipping through an hourglass. Whether the grains represent stars or seconds, the flow is unstoppable. What's truly humbling is how entropy connects these scales. A black hole's event horizon isn't just a boundary, it's a ledger recording every particle that falls in, much like the wrinkles on your skin record every laugh and squint at sunlight. And just as Hawking radiation slowly erases a black hole's mass, time erases our own markers. Memories fade, photos yellow, even mountains crumble. But here's the twist: entropy isn't about loss. It's about transformation. When a black hole evaporates, its energy doesn't vanish. It rejoins the universe's tapestry. Similarly, when a tree rots or a civilization falls, its atoms become soil, then new life, then stardust again. This is where the analogy deepens. Black holes teach us that entropy isn't the enemy of meaning, it's the canvas. Without it, there would be no change, no evolution, no stories. A universe stuck at perfect order would be a frozen clock, a snapshot without motion. The very heat death we fear, the distant future when entropy peaks and all energy disperses, is also what makes today possible. Your heartbeat, your thoughts, even your grief over fleeting time are only here because entropy allows the arrow of time to point forward. So when we say black holes and humans share this thermodynamic thread, we're acknowledging something profound. Mortality isn't a flaw. It's a feature of the universe's design. The chaos we resist is the same force that lets galaxies spin and children grow. Embrace the paradox. The universe forgets nothing, even as it unravels everything. Your existence, like a black hole's glow, is a temporary spark in an infinite exchange of energy precisely measured, utterly unique, and part of something far grander than decay. The black hole information paradox forces us to confront one of the most unsettling questions in physics, and perhaps in human existence. When something crosses a black hole's event horizon, it appears to vanish from our universe, shredded into its most basic particles. For decades, scientists assumed this meant information was erased permanently, violating a fundamental law of quantum mechanics. That information can never be destroyed. But what if disappearance is just an illusion? What if, like footprints in wet sand swallowed by the tide, the impression remains even when the details blur? This paradox mirrors our deepest existential fears. When a person dies, their memories, experiences, their unique data seem to evaporate into nothingness. But just as physicists now theorize that black holes encode swallowed information in their event horizons, we might ask whether human consciousness leaves its own subtle imprint on the fabric of reality. The holographic principle suggests that all the information falling into a black hole isn't lost, it's projected onto its two-dimensional surface, like a cosmic DVD storing three-dimensional data. If the universe can preserve the blueprint of annihilated stars, could it also retain echoes of human thought? Quantum entanglement adds another layer to this mystery. Particles separated by vast distances remain inexplicably linked, instantaneously mirroring each other's states. Some researchers propose that similar connections might tether information inside a black hole to radiation outside it, meaning nothing is ever truly isolated or erased. Translate this to human experience. If our minds arise from quantum processes in the brain, could some fragment of awareness persist in ways we don't yet comprehend? Consider the way a dying star's light continues traveling through space long after the star itself has collapsed. In a sense, the star hasn't vanished. Its energy simply exists elsewhere, untouchable but undeniably real. Human legacies operate similarly. A laugh recorded on an old tape, a name carved in stone, even the influence we've had on others. These are our Hawking radiation, faint but enduring signals that outlast our physical forms. Theories like black hole complementarity go further, proposing that information isn't just preserved, it's duplicated. An object falling into a black hole might appear destroyed to an outside observer while continuing intact beyond the horizon. This duality echoes ancient philosophical debates. Is death an end or a transition? A wall or a doorway? Science hasn't answered these questions, but the parallels are too striking to ignore. If information can't be destroyed, only transformed, perhaps the same applies to the essence of who we are. Here's the profound takeaway: the universe seems hardwired to remember. Whether through holograms, entanglement, or some deeper mechanism we've yet to discover, the cosmos resists absolute erasure. Black holes don't delete, they encrypt. And if that's true for collapsing stars, might it also be true for the flicker of human consciousness? We may not have proof yet, but the possibility alone redefines mortality, not as a void, but as a rearrangement. The atoms in your hand once dwelled in distant nebulae. Why couldn't the patterns of your mind linger too, woven into the universe's hidden code? Stephen Hawking's revelation that black holes aren't eternal, that they slowly leak energy into the void, shattered our understanding of cosmic permanence. Picture a glacier melting under an invisible sun, each droplet vanishing into the air. That's Hawking radiation. Particles escaping the black hole's grip through quantum fluctuations at the event horizon, chipping away at its mass over unimaginable timescales. The math is staggering. A black hole with the mass of our sun would take 10 to the power of 67 years to evaporate. Yet the message is intimate. Even the universe's most indomitable structures are ephemeral. Now hold that thought and feel your own pulse. Your body radiates heat just like a black hole, a quiet exchange of energy with the world around you. Every breath you exhale carries warmth. Every idea you share ripples outward. Hawking radiation isn't just astrophysics, it's a metaphor for human impact. We think of legacies as grand monuments or enduring artworks, but they're more like those escaping particles, subtle, persistent, woven into the fabric of reality long after we're gone. A child remembers your kindness decades later. A stranger quotes your words without knowing their source. These are the Hawking radiation of a life, invisible emissions that outlast their origin. The real surprise, this process defies classical intuition. Empty space isn't truly empty. It's a seething quantum foam where particle-antiparticle pairs constantly blink in and out of existence. At a black hole's edge, one particle falls in while the other escapes, stealing a tiny fraction of the hole's energy. It's as if the universe gifted black holes an expiration date, ensuring nothing hoards energy forever. We see echoes of this in biology. Cells dividing until their telomeres fray, forests burning to nourish new growth, civilizations rising and dissolving like waves. The cosmos abhors stagnation, whether in space-time or in us. Here's where it gets poetic. Hawking radiation implies that black holes, those symbols of oblivion, are paradoxically luminous. Their glow is faint but undeniable, like a candle flickering in a cathedral. Humans share this duality. We're fragile, yes, but also radiant. Consider how a single act of courage can inspire generations, or how a scientific breakthrough made centuries ago still shapes our lives today. Energy never dies, it just changes hands. The heat from your coffee cup disperses into the room. The light from dead stars still reaches our eyes, and the love you gave still warms someone's memory. So when we say black holes evaporate, we're really saying they participate in the universe's grand economy of energy. Nothing is hoarded, nothing is wasted. Your existence operates by the same rules. Every laugh, every tear, every moment of attention you've paid to the world is a form of Hawking radiation, escaping the event horizon of your life to join something larger. The abyss isn't just taking, it's giving back one particle at a time, and so do we. Time flows like a river, only forward, never backward. This isn't just poetic metaphor, it's the ironclad law of thermodynamics. Entropy, the universe's measure of disorder, is the invisible hand pushing that river in one direction, ensuring spilled milk never unspills and shattered glass never reassembles. Nowhere is this irreversible flow more dramatic than in the presence of a black hole, where gravity doesn't just bend space, it twists time into knots. Near the event horizon, clocks tick slower, stretching seconds into eons. Cross that boundary, and time's arrow doesn't just point forward, it points downward toward a singularity where all paths converge and stop. For humans, time's one-way street feels deeply personal. Wrinkles deepen, memories fade, and childhood homes shrink when revisited. We're haunted by the asymmetry of time. Why can we remember yesterday but not tomorrow? Why does nostalgia ache while anticipation excites? Black holes offer a cosmic mirror to this struggle. Just as matter falling into a singularity can never return, our own pasts become unreachable, sealed behind an event horizon of elapsed seconds. The moment your first love ended, the last words spoken to someone gone, these aren't just memories, they're relics trapped in time's gravity well. But here's the twist. Black holes don't just illustrate time's irreversibility, they amplify it. Einstein's relativity shows that near a black hole, tidal forces stretch objects into spaghetti, while time dilation warps their perception of reality. A clock on your wrist might tick normally while one near the event horizon crawls. This isn't science fiction. GPS satellites orbiting Earth must account for tiny time warps caused by our planet's gravity. Scale that up to a black hole and the effect becomes extreme. Imagine two astronauts, one hovering at a safe distance, the other descending toward the abyss. To the outside observer, the falling astronaut appears frozen at the horizon, their final moments stretched across eternity. Yet for the doomed traveler, time passes normally. They cross the threshold, unaware of their own infinite pause in someone else's eyes. This duality mirrors human mortality. To the universe, our 80-year lifespans are less than a blink, but subjectively, we experience every joy and sorrow in real time, each moment vivid and irreplaceable. The tragedy isn't that time ends, it's that we're acutely aware of its passing. Black holes, in their ruthless distortion of time, remind us that perspective is everything. The same force that makes stars collapse also gifts us the urgency to create, connect, and love before our personal hourglass runs dry. Thermodynamics adds another layer. Just as entropy ensures heat always flows from hot to cold, it guarantees that energy disperses, structures crumble, and complexity unravels. Black holes, despite their power, aren't exempt. Hawking radiation ensures even they evaporate, their mass energy eventually returning to the cosmos. This cosmic recycling echoes our own lives. The energy in your body, the calories you burn, the thoughts you generate, was once starlight and will one day be stardust again. The arrow of time doesn't erase, it redistributes. So when we say death is the ultimate point of no return, we're echoing physics. But the deeper lesson isn't despair, it's context. Time's flow is what makes choices meaningful, relationships precious, and art urgent. A universe where we could rewind would be one without consequence or crescendo. Black holes, in their terrifying majesty, teach us that irreversibility isn't a flaw, it's the foundation of narrative. Your life is a story precisely because its pages can't be rewritten. Every laugh, every regret, every leap of faith gains weight from the knowledge that time, like a black hole's gravity, only pulls in one direction, and perhaps that's the most human truth of all. Quantum immortality sounds like science fiction until you realize it stems from the same equations that predict black holes. At the heart of this controversial idea lies the many worlds interpretation of quantum mechanics, which suggests every possible outcome of an event spawns a new universe. In one branch of reality, you might step off a curb and meet tragedy. In another, a split-second hesitation keeps you alive. Proponents argue consciousness could theoretically navigate these branching paths indefinitely, perpetually landing in timelines where death is avoided. It's a dizzying thought, but here's where it gets eerily familiar. This mirrors how black holes defy classical expectations. Just as information isn't truly lost in a singularity, just scrambled beyond recognition, quantum immortality implies experience might not end, only diverge. Critics dismiss this as philosophical sleight of hand, and rightly so. There's no empirical evidence that consciousness hops between realities. Yet the parallel to black hole thermodynamics is hard to ignore. Both phenomena force us to confront the limits of our intuition. A singularity bends spacetime so severely that our physics breaks down. Quantum immortality does something similar to our understanding of self. If a black hole's event horizon is a veil hiding transformed information, could death be a veil hiding transformed consciousness? Not in a spiritual sense, but as a quantum process we lack the tools to measure. Consider Schrödinger's famous cat, both alive and dead in its box until observed. Now imagine the cat is you. In one universe, your story continues. In another, it doesn't. The unsettling implication is that from your subjective perspective, you'd only ever experience the timelines where you survive. This isn't about cheating death, it's about statistics playing out across infinite realities. Black holes offer a cosmic counterpoint. Just as Hawking radiation preserves energy across the event horizon, quantum immortality suggests experience might persist across probabilistic boundaries. But here's the rub. Even if this hypothesis held water, the you surviving in another universe wouldn't be the you reading this now. Memories, relationships, the continuity of identity, all would fork with each quantum decision. It's less like living forever and more like a cosmic game of telephone, where your consciousness fractures into increasingly distant echoes. Compare that to a black hole's fate. Information reemerges via Hawking radiation, but so scrambled it's functionally unrecognizable. Both scenarios trade permanence for transformation, leaving us to wonder, is continuity an illusion all along? The real value of this thought experiment isn't in its literal truth, but in how it reframes mortality. Black holes taught us that destruction is often rearrangement. Quantum immortality, however speculative, hints that the same might apply to the fabric of experience. Whether through parallel universes or thermodynamic echoes, the universe seems obsessed with preserving, not in the ways we might hope, but in ways that challenge us to think bigger. After all, if a dying star's light never truly vanishes, why assume awareness must? The universe, in its grand finale, won't end with a bang or a whimper, but with a sigh. A slow, inevitable sigh as the last black hole evaporates into nothingness, leaving behind a sea of particles so spread out that no star can ever ignite again. This is the heat death, a future so distant it makes the age of our cosmos seem like the blink of an eye, yet as certain as the cooling of your morning coffee. Thermodynamics guarantees it. Every process, from the fusion in stars to the firing of neurons in your brain, pumps entropy into the universe like coins into a cosmic slot machine. And one day, the machine will hit jackpot maximum disorder, zero usable energy left to spend. Now, hold that thought and look at your hand. The warmth you feel, the pulse beneath your skin, it's the same story playing out on a microscopic scale. Your cells are little engines fighting entropy with every beat, every breath, until they can't anymore. The heat death of the universe isn't just astrophysics, it's the ultimate mirror to our mortality. But here's where it gets strange. This bleak endpoint isn't tragic, it's necessary. Without the relentless march of entropy, life as we know it couldn't exist. The same force that will one day silence the cosmos also made possible every sunrise, every thunderstorm, every thought you've ever had. Black holes, those titans of gravity, are no exception to this rule. They might seem like eternal prisons, but Hawking radiation ensures even they'll fade, leaving behind only faint whispers of their existence. The last surviving black holes in the universe will be the size of atoms, glowing with the warmth of a dying ember before vanishing entirely. It's a haunting parallel to human life. No matter how massive our presence, how bright our light, we all return to the same equilibrium. The billionaire and the beggar, the genius and the forgotten, all heat signatures in the end. Yet there's a peculiar comfort in this cosmic symmetry. The universe doesn't discriminate in its finale. Galaxies, stars, civilizations, all are temporary wrinkles in the fabric of space-time, destined to be smoothed away. But here's the twist. Wrinkles are where the interesting things happen. A flat sheet can't hold a story. The very impermanence that dooms us also defines us. Imagine a universe where heat death wasn't inevitable. No decay would mean no change, no evolution, no art or love or discovery. Eternity would be a featureless plane, not a tapestry woven with fleeting brilliance. So when cosmologists speak of the universe's end, they're not just describing a far-off event. They're holding up a mirror to the human condition. Our lives are microcosms of cosmic time, brief flares against the dark, fueled by the same thermodynamic laws that govern quasars and supernova. The heat death isn't a verdict, it's a reminder. Every moment matters precisely because it can't last. The energy you expend today, whether in creativity, kindness, or curiosity, is your personal resistance against entropy. And while the universe may forget your name, it will never erase your impact. Like a black hole's hawking radiation, your influence disperses, joining the infinite dance of particles that began with the Big Bang and ends, fittingly, in silence. Black holes aren't born, they're forged in chaos. Picture a massive star burning bright for millions of years until one day its fuel runs out. The outward pressure of nuclear fusion can no longer fight the inward crush of gravity, and the star collapses in on itself in a cataclysmic supernova. What remains is a singularity, a point of infinite density where the laws of physics as we know them break down. This violent birth mirrors our own entry into existence. Think of the moment a sperm meets an egg, a microscopic explosion of potential, where genetic information collapses into a single cell that will divide and grow against all odds. Both processes, stellar collapse and human conception, are battles between creation and destruction, where order emerges from turbulence, but birth is just the first chapter. A black hole grows by devouring everything in its path: gas, stars, even other black holes, its event horizon expanding like a shadow swallowing light. Humans grow too, though far more delicately. We absorb nutrients, knowledge, experiences, building our own event horizons of memory and identity. Yet here's the catch: growth isn't infinite. For black holes, there's a limit to how fast they can consume before radiation pressure pushes material away. For humans, our cells can only divide so many times before telomeres fray and replication fails. This isn't failure, it's physics. The same thermodynamic laws that prevent perpetual motion machines also ensure no system, cosmic or biological, can hoard energy forever. Then comes the slow fade. A black hole's middle age is a quiet era of gradual decay, leaking Hawking radiation over eons like a tire with an invisible puncture. Human aging follows a similar curve, not a sudden collapse, but a gradual release. Muscle mass dwindles, metabolism slows, and memories blur at the edges. But just as Hawking radiation carries traces of what fell into the black hole, our later years radiate the accumulated wisdom of a lifetime. The energy doesn't vanish, it transforms. A grandfather's story told to a grandchild, a scientist's discovery passed to a student. These are the human equivalent of particles escaping the event horizon. The final stage is where the analogy becomes most poignant. An isolated black hole, cut off from new material, evaporates completely, its mass energy returning to the universe as harmless radiation. No fanfare, no explosion, just a quiet dispersal. Human death, when stripped of cultural rituals, operates on the same principle. The body's energy, the heat, the chemical bonds, even the electrical impulses of thought dissipates into the environment. Soil absorbs our atoms, plants convert our carbon, and the calories we once burned now fuel other life. It's not an end but a redistribution, as inevitable as the black holes return to the cosmic background. What makes this comparison humbling is the timescale. A stellar mass black hole might take a trillion years to evaporate, while humans average 80. But proportionally, both lifespans are equally fleeting against the age of the universe. This isn't depressing, it's unifying. Whether you're a singularity warping space-time or a collection of cells reading this script, you're playing by the same rules: growth fueled by external energy, stability maintained until entropy wins, and an eventual return to the universe's fabric. The difference isn't in the arc, but in how each of us, black hole or human, spends the borrowed time between formation and fade. What if the universe keeps its books balanced not just through impersonal laws, but through something far more intimate, conscious observation? The idea that awareness might influence reality sounds like mysticism, yet it emerges from the cold equations of quantum mechanics. Take the famous double-slit experiment. When unobserved, particles behave as waves, creating interference patterns. But the moment a detector is introduced, they snap into definite positions like soldiers caught in a spotlight. This observer effect suggests that at quantum scales, measurement isn't passive. It actively shapes outcomes. Now stretch that concept across the cosmos. If a lab instrument can alter particles, could trillions of conscious observers, human or otherwise, subtly steer the universe's thermodynamic dance? Black holes add a provocative layer to this puzzle. As we've seen, they don't destroy information. They encode it on their event horizons like cosmic hard drives. But here's the twist. That information only becomes meaningful when reconstructed by an external observer analyzing Hawking radiation. Without observation, the data remains scrambled, trapped in quantum ambiguity. This mirrors how human experience collapses probability into certainty. The tree falling in the forest makes sound waves, but sound, as we understand it, requires an ear to translate vibrations into perception. The universe may operate similarly, its thermodynamic processes fully realized only through interaction with conscious systems. Critics argue this veers into anthropic fallacy, assuming the cosmos caters to human-like awareness. Yet even skeptics admit that entropy's arrow aligns suspiciously well with the conditions needed for life. The universe began in low entropy, allowing complexity to arise, and will end in high entropy when all energy disperses. In between, just enough structure exists for observers to emerge and ponder the process. Coincidence or clue? Some theorists propose that consciousness isn't just a byproduct of thermodynamics but a participant, like a black hole's event horizon that filters chaos into measurable order. Consider the butterfly effect on a cosmic scale. A single thought, say, your decision to watch this video ripples outward, altering neural pathways, influencing conversations, perhaps even steering your future actions. Multiply that by 8 billion minds, each making countless observations daily. While negligible compared to galactic forces, these cumulative acts of attention might nudge the universe's trajectory, much as trillions of photons collectively bend spacetime around a black hole. The math remains hazy, but the principle resonates. Observation isn't neutral. Every time you focus on a star, recall a memory, or solve a problem, you're not just processing information, you're voting on what reality becomes. This isn't to suggest humans are cosmic arbiters. Rather, consciousness might be one thread in a vast tapestry of self-referential processes. Black holes encode information, stars fuse elements, life converts energy into awareness, all part of the universe's relentless computation. The eerie harmony between thermodynamics and cognition hints at something profound. The boundary between out there and in here may be thinner than we think. After all, if a singularity can warp the fabric of spacetime, why couldn't a symphony of conscious observers subtly tune the universe's song? The answer, like light at the edge of a black hole, remains just beyond our grasp, but the question itself illuminates new paths between mind and cosmos. Near-death experiences and black holes share an uncanny visual poetry: the tunnel, the light, the irreversible threshold. Those who have brushed against mortality often recount floating through a dark passage toward a radiant glow, feeling both pulled and at peace. It's a description that could just as easily depict matter spiraling toward a black hole's event horizon, where gravity stretches everything into a long, thin stream. Of course, the human brain under duress isn't a telescope trained on a singularity. But when similar imagery emerges across cultures and centuries, it's worth asking, why does the edge of death mirror the edge of oblivion in our collective imagination? Neurology offers one clue. During oxygen deprivation, the brain's visual cortex fires erratically, creating tunnel-like patterns as peripheral vision fails first. The light, possibly a surge of dopamine or dimethyltryptamine natural compounds linked to euphoria and vivid hallucinations. Yet this mechanical explanation feels incomplete. Black holes, after all, are literal tunnels in spacetime where light bends into a singular point. The parallel suggests something deeper, that our minds, when untethered from the body's constraints, might tap into a metaphorical vocabulary as old as the cosmos itself. Consider the physics. Crossing a black hole's event horizon is a one-way trip, but not an instantaneous annihilation. To an outside observer, you'd appear frozen at the threshold, your final moments stretched across eternity. To you, time would flow normally as you slid toward the singularity. Near-death experiencers report something similar, a dissociation where time distorts, memories accelerate, and the body's limits fall away. The common thread isn't just imagery, it's the shared sensation of transitioning between states where the rules of ordinary existence no longer apply. Then there's the light. For a black hole, the glow comes from Hawking radiation particles escaping the horizon's grip. For near-death experiencers, the light often feels sentient, even loving. Could this be the brain's way of simulating the universe's most fundamental exchange? Energy never dies, it just changes hands. The warmth described by those who have returned might symbolize that same thermodynamic truth. A fleeting consciousness merging back into the cosmic reservoir, if only for a moment. The most haunting parallel is information preservation. Black holes scramble data but don't destroy it, encoding it on their surfaces like celestial archives. Near-death accounts frequently include life reviews, flashes of memory replaying in vivid detail. If consciousness is a form of quantum information, could these reviews be the mind's last-ditch effort to back itself up, imprinting its essence onto some deeper layer of reality? It's speculative, but so was Hawking's radiation until we detected its fingerprints in the math. Skeptics rightly caution against conflating metaphor with mechanism. The brain under stress is a storyteller, not a physicist. Yet the persistence of these motifs across epochs, religions, and now astrophysics hints that something primal is at work. Whether it's neural circuitry echoing cosmic structure or something more mysterious, the overlap between event horizons and near-death visions reminds us that mortality, like a black hole, is a frontier where science and wonder collide. And perhaps that's the most human lesson of all. We're hardwired to find meaning in the abyss, even as it stares back. The holographic principle turns our understanding of reality inside out, literally. Imagine standing in front of a mirror, but instead of reflecting just your surface, it somehow contains every thought, memory, and atom inside your body. That's the radical idea at play here. The universe might operate like a cosmic hologram, where all the information needed to construct three-dimensional reality, stars, planets, even human consciousness, is encoded on a two-dimensional boundary. For black holes, this isn't just theory. The event horizon's surface area mathematically holds all the information about what fell inside, like a celestial barcode. Scale that up, and the entire cosmos could be a vast projection, with us living in the illusion of depth while the real data resides on some distant, flat plane we can't perceive. This isn't science fiction. Physicists arrived at this conclusion through cold, hard math specifically, by trying to reconcile gravity with quantum mechanics. The equations revealed something startling. The maximum entropy or information content of any region of space doesn't scale with its volume as you'd expect, but with its surface area. It's as if the universe has a built-in compression algorithm, squeezing 3 dimensions into 2 like a cosmic zip file. Black holes demonstrate this perfectly. No matter how much you toss into a singularity, the information never exceeds what can be written on its event horizon's surface. The rest just shadows on the cave wall of existence. Now shift perspective to human experience. If reality is a hologram, what does that say about our lives, your memories, your sense of self? Could they be projections of data stored elsewhere, like reflections in a pond? Ancient philosophies hinted at this. Plato's allegory of the cave described prisoners mistaking shadows for reality, while Eastern traditions speak of Maya, the illusion masking ultimate truth. Modern science, bizarrely, is now flirting with similar ideas. The holographic principle suggests that free will, even time itself, might be emergent properties, side effects of a deeper, simpler reality we're not equipped to see. Here's where mortality enters the frame. If we're holograms, death might not be deletion, just a transfer of data. Think of a video game character unaware it's made of code. When the game ends, the character doesn't die, the code persists, waiting to be run again. Similarly, if your consciousness is information encoded on the universe's boundary, your end in this dimension could be a continuation elsewhere, rewritten into some grander cosmic narrative. Black holes model this eerily well. When matter falls in, it's not destroyed. Its information gets scrambled onto the horizon's surface, preserved in a form we don't yet understand how to read. The implications ripple outward. If the holographic principle holds, the universe isn't just stranger than we imagine, it's stranger than we can imagine. Our struggles, loves, and losses might be threads in a tapestry woven at light years remove, where time and space are mere pixels in a deeper display. This doesn't diminish human experience, it elevates it. Every choice you make could be a fluctuation in the cosmic code, a note in a symphony playing on the edge of reality. The abyss gazes back, yes, but what if it's also writing us into existence, one quantum bit at a time? The fleeting nature of black holes whispers a paradoxical truth, that meaning isn't found in permanence, but in the delicate tension between being and vanishing. Consider a diamond and a soap bubble. One lasts centuries, the other mere seconds, yet their beauty isn't measured by duration but by the intensity of their existence. Black holes embody this principle on a cosmic scale. Their evaporation isn't a flaw, it's what makes them dynamic participants in the universe's story. Without the inevitability of their end, they'd be static monuments, not actors in the grand thermodynamic drama. Humans operate by the same rules, the knowledge that our time is limited, that our energy will one day disperse like Hawking radiation, is what lends urgency to our choices, depth to our relationships, and weight to our creations. Philosophers have wrestled with this idea for millennia. The ancient Stoics taught that contemplating mortality sharpens appreciation for the present, while Buddhist traditions embrace impermanence as the root of compassion. Modern existentialists like Camus argued that life's lack of inherent meaning forces us to create our own. Black hole thermodynamics offers a scientific parallel. Entropy isn't just decay, it's the engine of change. A universe where black holes never evaporated would be one without stellar recycling, without the dispersal of heavy elements needed for planets and life. Our mortality, like a black hole's, isn't an accident. It's a prerequisite for the cosmic dance itself. Think of a symphony. If the notes lingered forever, there'd be no movement, no progression. The silence between chords is what makes the music. Similarly, the finite lifespan of stars, black holes, and humans creates the rhythm of the universe. Every act of love, every scientific discovery, every moment of courage gains its significance from the unspoken backdrop of impermanence. Even black holes, those titans of destruction, contribute to this cadence. Their radiation seeds the void with energy, their gravity sculpts galaxies, and their eventual disappearance makes room for new structures to emerge. Here's the radical implication. Purpose might not be something we find, but something we forge through our response to transience. A black hole doesn't know it's radiating energy, yet that process shapes the cosmos. Humans, however, are uniquely aware of our evaporation, and that awareness transforms entropy from a sentence into a canvas. The artist who paints knowing the mural will fade, the parent who cherishes a child's fleeting laughter, the scientist who researches despite knowing her name will be forgotten. These aren't acts of futility. They're defiance in the face of thermodynamics, proof that meaning isn't stored in atoms but in the spaces between them. The holographic principle adds another layer. If our reality is a projection of information encoded on some distant boundary, then our lives are stories written in quantum ink. A black hole's event horizon records its history in spacetime's geometry. Human culture does the same through language, art, and shared memory. Both systems suggest that existence isn't about permanence but about resonance, the way our actions ripple through the universe's fabric long after we're gone. A black hole's gravity bends light from stars it will never touch. A single human idea can bend history centuries later. So do black holes solve the riddle of life's purpose? No, but they reframe the question. The universe doesn't deal in eternal answers. It deals in processes, relationships, and transformations. Your life, like a black hole's, is a temporary knot in spacetime's fabric, gathering energy only to release it again. But in that gathering, in the heat of your passions, the gravity of your connections, the light you cast before fading, you participate in something vast. Not eternal, but infinite in its iterations. The cosmos remembers in its own way, not through monuments but through the relentless, beautiful recycling of energy and information. And perhaps that's enough. The pursuit of immortality isn't just a scientific challenge, it's a philosophical tightrope walk over the abyss of unintended consequences. Picture a world where death is optional, where biological aging is a glitch we've patched like outdated software. At first glance, it sounds like utopia. But black holes, those relentless enforcers of cosmic impermanence, remind us that everything, even the universe's most indomitable structures, has an expiration date. Their gradual evaporation through Hawking radiation isn't a design flaw. It's a feature of a universe built on cycles of renewal. If even singularities can't escape entropy's grip, why should we assume humans were meant to? This isn't just poetic musing. Thermodynamics shows us that closed systems, whether stars, civilizations, or ecosystems, require turnover to thrive. Forests need decaying wood to nourish saplings. Oceans rely on plankton deaths to sustain food chains. Human culture, too, depends on generational succession. New ideas often emerge not in spite of mortality, but because of it. The Renaissance didn't happen because medieval thinkers lived forever. It bloomed when fresh perspectives challenged entrenched dogmas. Immortality might freeze society in perpetual stasis, like a black hole that never releases its energy back into the cosmos. Yet the ethical dilemma runs deeper. Who gets to live forever? In a world where lifespan extension exists, access would likely follow the same brutal inequities as healthcare today. The wealthy could buy centuries, while others age and die on schedule. This isn't speculative. We already see it with cutting-edge therapies priced beyond reach. The result? A dystopia where the privileged become near-immortal oligarchs, hoarding resources across epochs while the rest become transient shadows in their endless reign. Black holes don't discriminate in their decay, they radiate energy indiscriminately. Human societies, tragically, might not be so equitable. Then there's the psychological toll. Our brains evolved to navigate roughly 80-year lifespans, not millennia. Memories could overflow like corrupted hard drives, identities fracturing under the weight of centuries. Relationships would strain as people outgrow each other at different rates, like stars in a binary system where one collapses into a black hole, warping the bond beyond recognition. Even if we solved the biology, could we handle the existential weight of watching galaxies drift while we remained unchanged? Perhaps the most profound argument against cheating death comes from cosmology itself. The universe's creativity relies on destruction. Stars die to spread elements for planets. Black holes evaporate to seed new structures. If nothing ever ended, nothing new could begin. Human culture mirrors this. Art gains urgency from its ephemerality. A sunset moves us precisely because it fades. The knowledge that time is limited doesn't diminish meaning. It concentrates it, like light bent around a singularity. This isn't to reject life extension outright. There's nobility in easing suffering, in adding decades of health to the human experience, but true immortality. That might unravel the very fabric of what makes existence precious. Black holes teach us that boundaries, event horizons, lifespans, thermodynamic limits aren't just constraints. They're the frame around the painting, the silence between musical notes. Without them, the universe would be a static void, and life, however long, would risk becoming an endless echo in an uncaring sky. Long before telescopes pierced the heavens, humans saw their own stories written in the night sky. The ancient Egyptians envisioned the sun god Ra sailing through the underworld each night, dying at dusk only to be reborn at dawn, a celestial echo of their belief in cyclical renewal. Halfway across the world, Hindu texts describe the universe breathing in and out over epochs, with each exhalation dissolving worlds and each inhalation birthing new ones. These weren't just myths, they were early intuitions about a truth modern astrophysics confirms. Destruction and creation are two sides of the same cosmic coin. Black holes embody this duality with startling elegance. When a star collapses into a singularity, it doesn't just vanish, it becomes the engine for new phenomena. Jets of plasma shoot from its poles at near light speed, triggering star formation in distant gas clouds. Swallowed matter reappears as Hawking radiation, seeding the void with energy for future structures. Even the supermassive black holes at galactic centers act as gravitational anchors, their violent feasts helping shape spiral arms where new solar systems coalesce. The universe, it seems, has always known what human cultures sensed instinctively. Endings are often disguised beginnings. This pattern reverberates through humanity's spiritual traditions. Buddhism's wheel of samsara mirrors the astrophysical cycle of stellar death and rebirth, where consciousness transitions between forms like energy shifting between states. Norse mythology's Yggdrasil, the world tree, whose roots drink from cosmic wells, parallels how black holes both consume and nourish their galactic environments. Even the phoenix, that universal symbol of resurrection, finds its counterpart in quasars, black hole-powered beacons that light up the early universe like fiery rebirths after cosmic dark ages. Contemporary science frames these cycles in equations, but the underlying wisdom remains unchanged. The carbon in your cells was forged in dying stars. The oxygen you breathe was scattered across space by supernova. Every atom in your body has crossed its own event horizon of transformation, surviving not through permanence but through perpetual reinvention. Indigenous Australian songlines capture this perfectly, mapping landscapes as both physical places and stories sung into existence, much like how black holes encode information on their surfaces, turning destruction into a kind of cosmic memory. What unites these perspectives isn't just poetic coincidence. It's a fundamental recognition that linear time, birth, life, death is only part of the story. The Maya measured time in nested cycles, their long count calendar tracking vast epochs like astronomers chart stellar generations. Modern physics reveals a similar fractal rhythm. Particles fluctuate in quantum foam, stars pulse through main sequences, galaxies spin through mergers, all moving to the same thermodynamic cadence. Perhaps this is why black holes captivate us so deeply. They're not just astronomical objects, they're mirrors reflecting humanity's oldest questions. When a Tibetan monk creates a sand mandala only to sweep it away, or a Japanese cherry blossom festival celebrates fleeting beauty, they're channeling the same truth written in the life cycle of stars. Mortality isn't a wall, it's a wheel turning through phases of gathering and release. And in that turning, we find our place not apart from the cosmos, but as its conscious expression, stardust that learned to wonder about itself. Grief bends the fabric of our lives like space-time warping around a singularity. That heavy emptiness in your chest after loss, it's not just metaphor, it's physics. Einstein showed us that mass distorts the universe's canvas, creating gravity's pull. Emotional gravity works the same way, bending memories into loops where past and present collide. A song, a scent, a turn of phrase can become event horizons, points where joy and sorrow orbit too close to escape. But here's what black holes teach us about this pain. Distortion isn't destruction. When light passes a massive object, its path curves, yet the photons remain intact. Grief, too, twists our trajectory without erasing what we carry. Thermodynamics adds another layer. The first law states energy never vanishes, only transforms. A campfire's heat dissipates into the night, but every calorie still exists, warming the air, stirring molecules, nudging weather patterns. Human connections operate by the same rule. The love you poured into someone, the hours shared, the laughter traded, those aren't annihilated by death. Like Hawking radiation carrying a black hole's fingerprint into the void, relationships leave indelible marks on reality's ledger. Scientists debate whether information swallowed by singularities truly disappears or merely encrypts itself in quantum code. Grief poses a parallel question. Do bonds severed by mortality end, or do they shift into forms our senses can't decode? Consider quantum entanglement, where particles separated by light years mirror each other's states instantly. Some researchers speculate consciousness might exploit similar links, that minds who have intertwined could retain subtle resonances beyond physical separation. It's not mysticism, it's the universe's insistence that nothing exists in isolation. A black hole's gravity tugs on stars it will never consume. Likewise, those we've lost still influence our orbits through inherited mannerisms, half-remembered advice, or the quiet way their absence reshapes our choices. Memory itself behaves like cosmic background radiation, the afterglow of creation. Just as telescopes detect photons from the Big Bang, aged 13 billion years, our minds replay moments with crystalline clarity decades later. The brain doesn't store memories like files in a cabinet. It reconstructs them dynamically, each recollection subtly altering the original. This mirrors how black holes encode information holographically, not as discrete packets, but as patterns woven across a surface. Your happiest moments with someone gone aren't locked in the past. They're alive, evolving with every retelling, every new context you bring to them. Wave-particle duality offers another lens. Light exists as both particle and wave until observed. Grief, too, oscillates between states: sharp pain one moment, soft nostalgia the next. The act of remembering collapses these possibilities into a single experience, much like measuring a quantum system forces it to choose. This fluidity hints that emotions might obey their own conservation laws. A sob stifled today doesn't vanish. It lingers in tightened muscles or erupts later in unexpected tears. The universe balances its books, and so does the heart. Perhaps this is why black holes resonate so deeply with mourners. They embody the paradox at grief's core: what seems gone isn't. Matter crushed from view still shapes its surroundings through gravity. Laughter silenced still echoes through choices it once inspired. Physics doesn't do eulogies, but it whispers this comfort: energy is stubborn. It resists erasure, whether in the depths of a singularity or the quiet corners of a grieving mind. The warmth you miss hasn't dissipated. Like starlight traveling long after its source expires, it's still reaching you, just on wavelengths the naked eye can't see. Black holes don't just swallow matter, they erase the very rules of physics as we know them. Beyond the event horizon, the familiar laws of time and space crumble, leaving scientists to theorize about what might lurk in that unfathomable dark. Some models suggest a singularity, a point of infinite density where all captured matter is crushed into a pinprick of unreality. Others propose wilder possibilities: wormholes tunneling to distant corners of the cosmos, layers of space-time folded like origami, or even entire universes budding inward like inverted branches of a cosmic tree. This isn't just speculation, it's the frontier of human understanding where mathematics and imagination collide. The parallel to human mortality is unsettling. Just as we'll never peer inside a black hole, no one returns to report what lies beyond death's threshold. Ancient civilizations envisioned underworlds and afterlife realms, places where souls journeyed through trials or rested in eternal fields. Modern physics offers its own versions: quantum immortality, holographic consciousness, or the multiverse's infinite variations. Both frameworks, mythological and scientific, grapple with the same unnerving truth: some borders are crossed only once, with no return tickets. Consider the fate of a star collapsing into a black hole. From the outside, its demise looks final: a violent crunch, then silence. But relativity suggests another perspective. To an astronaut falling in, the journey might feel endless rather than abrupt. Time dilates so severely that the moment of crossing the event horizon stretches into eternity from an outsider's view. Could death hold a similar duality? Medical accounts of near-death experiences often describe time distortion, lives flashing by in seconds, or moments stretching into lifetimes. Physics can't confirm these subjective reports, but the symmetry is haunting. Then there's the information paradox. If black holes preserve data on their surfaces like cosmic gravestones, what does that imply about human legacies? Our bodies may decompose, but the impact of our actions ripples outward: genes passed to offspring, ideas etched into culture, carbon atoms cycling back into ecosystems. In this light, tombstones aren't endpoints, they're event horizons, marking where a life's visible form gives way to less tangible but equally real influences. A black hole's entropy is calculable, a human's isn't, but both leave fingerprints on the universe. The most radical theories blur the line between tomb and gateway. Some models posit that black holes spawn white holes, in other universes theoretical exits where all ingested matter is reborn. It's a poetic notion: death here as birth elsewhere. Human cultures have long embraced similar metaphors: the phoenix rising from ashes, the Hindu concept of reincarnation, even the scientific certainty that our atoms will someday form new stars. Whether through physics or folklore, we keep circling the same idea: Endings might be illusions, veiling transitions we don't yet comprehend. This is the chilling beauty of black holes. They force us to confront the limits of knowledge while hinting at possibilities beyond our grasp. A tomb implies finality, but the universe trades in transformation. Even light, once trapped, reemerges as Hawking radiation, not the same, but not gone. So perhaps the question isn't whether black holes are tombs or gateways. Perhaps they're both, cosmic metaphors for the paradox that defines existence. Nothing truly vanishes. It just changes form in ways we're still learning to see. Black holes sculpt galaxies with the same invisible hand that writes the rules of our mortality. Far from being cosmic wrecking balls, these gravitational giants act as architects, their influence stretching far beyond their event horizons. Picture a supermassive black hole at a galaxy's heart. It doesn't just sit there ominously. Its gravity choreographs the dance of billions of stars, while the energy it emits during feeding frenzies can trigger or suppress star formation across light years. When a black hole feasts on surrounding gas, the resulting friction heats material to millions of degrees, creating blazing quasars whose energy outshines entire galaxies. These outbursts act like cosmic pruning shears, clearing regions of space where new stars can later form while compressing gas clouds elsewhere to spark stellar nurseries. It's a paradoxical cycle: destruction enabling creation, endings birthing beginnings. Human civilization operates by the same fundamental rhythm. Consider how the passing of one generation makes room for new ideas to take root. The Renaissance didn't bloom because medieval scholars lived forever. It flourished when fresh perspectives challenged entrenched worldviews. Just as black holes regulate galactic ecosystems through their life cycles, mortality ensures cultural evolution through turnover. The wisdom of ancestors becomes soil for future growth, their experiences transformed like starlight reprocessed through interstellar dust. Even our cells follow this pattern. Apoptosis, or programmed cell death, removes damaged units so tissues can renew themselves. From the microscopic to the galactic, existence depends on this delicate balance between preservation and release. The parallels deepen when we examine feedback loops. A black hole's activity can create conditions that eventually starve it, like winds from its accretion disk blowing away the very gas it feeds upon. Human societies experience similar self-regulating dynamics. The Industrial Revolution's advancements led to climate challenges that now demand innovative solutions. Both systems demonstrate how growth contains the seeds of its own transformation. Even the Milky Way's central black hole, Sagittarius A, appears relatively quiet now, its past outbursts having shaped our galactic neighborhood into its current stable configuration. Civilizations too experience these cycles of turbulence and equilibrium, where periods of rapid change settle into eras of consolidation. Perhaps most strikingly, both black holes and human legacy operate through indirect influence. A supermassive black hole comprises just a tiny fraction of its galaxy's mass, yet its gravity governs motions far beyond its size. Similarly, individuals shape cultures disproportionately through ideas that ripple across centuries. The inventions of Marie Curie, the philosophies of Confucius, the art of Frida Kahlo, these are the Hawking radiation of human existence, particles of influence escaping their original context to nourish distant futures. A black hole's true power lies not in what it consumes, but in how it rearranges its surroundings. Our mortality gifts us the same creative constraint: finite time to create echoes that outlast our physical forms. This interplay between limitation and creativity manifests in unexpected ways. Just as galaxies with more active black holes tend to produce more stars, societies that confront mortality directly often experience cultural flourishing. Ancient Egypt's elaborate burial practices coincided with architectural and mathematical breakthroughs. Japan's Edo period, influenced by Buddhist impermanence, gave rise to exquisite woodblock prints and haiku poetry. The urgency imposed by time's arrow, whether cosmological or biological, doesn't stifle expression. It focuses and intensifies it. Black holes show us that the universe doesn't waste its endings. It reinvests them, channeling what was into what could be. So when we peer at distant galaxies shaped by their central singularities, we're not just observing astrophysics. We're witnessing a universal principle written across scales, that destruction and creation aren't opposites, but partners in an endless dance. The same force that carves cavities in nebulas where stars will later shine also clears space in human societies for new growth. Mortality, like a black hole's gravity, isn't the enemy of existence. It's the unseen architect shaping the structures that allow light, whether stellar or cultural, to keep shining in ever-changing forms. Time near a black hole doesn't just slow down, it warps into something unrecognizable. Imagine two astronauts, one orbits safely at a distance, while the other descends toward the event horizon. To the outside observer, the falling astronauts' movements grind to a near halt, their final approach stretched across eternity like a film reel stuck on its last frame. Yet for the astronaut themselves, time flows normally. They'd cross the threshold unaware of their own frozen image in someone else's universe. This isn't science fiction. It's the brutal honesty of Einstein's relativity, where gravity doesn't just bend space, it twists time into knots. Human perception mirrors this duality in eerie ways. Think of an hour spent laughing with friends, it vanishes like breath on glass. Now recall 60 minutes in a dentist's chair or a hospital waiting room, each second thick as syrup. Our brains don't measure time with atomic precision. They edit reality like capricious filmmakers, expanding moments of pain and compressing joy. Neurologists trace this to the amygdala, which stamps emotional events with heightened clarity, making traumatic memories loom larger in mental timelines. A black hole's gravity well and the mind's emotional weight share a strange kinship. Both distort the fabric of experience, proving time is never just a ticking clock. The relativity of aging adds another layer. If you could orbit near a black hole's edge for what felt like a week, decades might pass on Earth. Return home to find loved ones aged or gone, their lives accelerated while yours barely moved. This cosmic time theft mirrors earthly absences, soldiers deployed, explorers venturing forth, even workaholics glancing up to find their children grown. The difference is scale, not essence. Time's elasticity binds the cosmic and the personal, revealing how closely existence is tied to perspective. A mayfly lives one day, a tortoise centuries, yet both experience their lifespans as complete. Here's where mortality sharpens the paradox. The knowledge that our time is limited should, in theory, make every moment equally precious. Yet we live as if some hours are disposable, scrolling screens, grinding through routines, treating life like an infinite resource. Black holes offer a corrective. Their unforgiving physics show time as finite and non-renewable, warped but never reversed. The universe permits no do-overs, no second passes at the event horizon. This urgency isn't meant to paralyze, but to focus, like an astronaut deciding what messages to send home before crossing the point of no return. Quantum physics complicates things further. At microscopic scales, time may not even flow in one direction. Particles can exhibit retrocausality, where effects precede causes. Some theorists suggest our linear experience of time emerges from larger-scale thermodynamics, the same entropy that guides black hole evaporation. If true, our perception of aging is a kind of cosmic illusion, a shadow cast by deeper laws. Yet illusions have power. The pain of a fleeting childhood, the ache of watching parents age, these feelings are real even if their framework is relative. A black hole's time warp is no less profound for being situational. So what's the takeaway? Not that time is arbitrary, but that its value lies in how we inhabit it. Near a singularity or in a suburban kitchen, the present is the only territory we truly hold. The astronaut frozen at the horizon from one viewpoint is already vanished from another, yet in their own frame, they're simply living until they aren't. Mortality's gift is the clarity that frames matter. Zoom out and a human life is a blip. Zoom in and it's an epic. Both are true. The trick is choosing which lens to wear when. A black hole's isolation is absolute. No light escapes, no signal reaches out. Its entire existence shrouded behind an event horizon that severs contact with everything it once knew. Astronomers call this a causally disconnected region of space-time, a place where the universe's normal rules of connection no longer apply. Human loneliness operates by similar physics. Grief, depression, or even profound introspection can erect invisible event horizons around us, distorting our perception until the world outside feels unreachable, its comforting noises muted as if heard from underwater. The irony is crushing. In an age of hyperconnectivity, more people report feeling cosmically alone than ever before, trapped in subjective singularities where empathy and understanding struggle to cross the boundary. Consider how a black hole forms. A star collapses not from weakness, but from the sheer weight of its own accumulated matter, layers of unprocessed experience pressing inward until the core can no longer sustain itself. Human isolation often follows the same catastrophic density. The silent accumulation of unspoken fears, unresolved traumas, or simply the daily friction of being misunderstood compresses the psyche until connection seems impossible. Like a dying star, we don't choose isolation. It's the universe's ruthless response to exceeding some critical threshold of unshared weight. Yet here's where the metaphor deepens. Black holes aren't truly isolated. They're hyperconnected in ways that defy classical intuition. Their gravity tugs on distant stars, their accretion disks blaze with stolen matter, and their Hawking radiation whispers secrets into the void. Similarly, the most isolated human still casts gravitational ripples through unanswered texts that worry a friend, through creative work that outlasts its maker, through the mere fact of their absence altering someone else's orbit. The illusion of disconnection is just that, an illusion. When novelist Virginia Woolf filled her pockets with stones and walked into the river ooze, she left behind words that would pull generations of readers into her luminous, fractured inner world. Her event horizon wasn't the end. It was a transformation point where pain became art. Quantum physics offers another perspective. Entanglement proves particles can be inextricably linked across vast distances, instantaneously mirroring each other's states. Some theorists suggest consciousness might exploit similar phenomena, that isolation could be a trick of perception rather than objective reality. The bereaved often report sensing a lost loved one's presence. The clinically depressed might intellectually know they're cared for while feeling utterly alone. Like light bending around a black hole's edge, human connection doesn't always travel in straight lines. Perhaps the most poignant parallel is in how both black holes and isolated humans radiate. Hawking radiation arises from quantum fluctuations at the event horizon, particles born from nothingness, carrying traces of what fell inside. Human creativity often works the same way. Emily Dickinson wrote nearly 1,800 poems in her Amherst bedroom, most unpublished in her lifetime. Van Gogh sold one painting while alive, yet posthumously transformed art history. Their isolation wasn't a void but a crucible, compressing experience until it escaped as something new. The universe has a cruel habit of making brilliance and suffering share the same event horizon. This isn't to romanticize loneliness. Black holes don't choose their fate, and neither do most who suffer profound isolation. But understanding the mechanism changes how we view both phenomena. When astronomers study active galactic nuclei, supermassive black holes flaring with energy, they now see not just destroyers but regulators, shaping entire galaxies through their solitary dance. Human isolation, too, might be less a prison than a strange attractor in the chaos of existence, a phase where the psyche reorganizes itself at densities normal life can't sustain. The light we miss may not be gone, just bent into wavelengths we don't yet know how to see. Resilience isn't just a human trait, it's woven into the fabric of the universe itself. Picture a black hole, that ultimate symbol of cosmic destruction, slowly leaking energy back into the void through Hawking radiation. Even as it succumbs to entropy's pull, it resists total annihilation, transforming its own decay into particles that drift across the cosmos. Humans mirror this defiance in ways both profound and everyday. Every time a surgeon repairs a failing heart, a scientist extends a battery's lifespan, or an artist preserves a moment in paint or verse, we're engaging in the same fundamental struggle, pushing back against the universe's relentless slide toward disorder. Medicine offers one of the clearest parallels. Consider telomeres, the protective caps on our DNA that fray with each cell division like a wick burning down. Aging at its core is entropy playing out in our biology, yet we've developed therapies to lengthen these molecular timers, just as Hawking radiation stretches a black hole's demise across epochs. Vaccines are another triumph, tiny imprints of invaders we weaponize to preempt chaos in our immune systems. It's as if we've taken a page from quantum physics, where information resists erasure even in the face of oblivion. Art and culture amplify this resistance. A symphony composed in the 18th century still vibrates air molecules today, its ordered patterns resisting the dispersion of sound waves into noise. The cave paintings of Lascaux have outlasted countless civilizations, their pigments clinging to rock while mountains eroded around them. These creations are humanity's Hawking radiation particles of meaning escaping the event horizon of their era to warm future generations. Even digital data follows this principle. When archivists encode ancient texts on nickel plates designed to last thousands of years, they're building cultural event horizons, surfaces where knowledge is preserved against time's relentless tide. Legacy operates on a grander scale. Just as a black hole's gravity shapes entire galaxies long after its formation, human actions ripple through centuries in ways both visible and unseen. The agricultural techniques developed by indigenous cultures millennia ago still inform sustainable farming today. A teacher's encouragement might echo in a student's descendants 7 generations later, like light bent around a singularity. This isn't metaphorical, it's thermodynamic. Energy cannot be created or destroyed, only transferred. The kindness you offered a stranger last Tuesday still exists in the universe's ledger, folded into the fabric of causality like a photon emitted from the edge of a black hole. The true lesson lies in the mechanisms of this resilience. Black holes don't resist entropy through brute force, they exploit quantum loopholes, turning the vacuum itself into a release valve. Humans, too, find our most potent tools at the boundaries of understanding. CRISPR gene editing manipulates life's code at the molecular level, much as Hawking radiation emerges from quantum fluctuations. Blockchain technology prevents data corruption by distributing information across networks, mirroring how black holes encode their history holographically across their surfaces. Even our social systems reflect this democracy, for all its flaws, resists the entropy of authoritarian collapse by distributing power like energy across a system. Yet there's a humility in this struggle. No star, not even the most massive, avoids eventual collapse. No human, no matter how brilliant or resilient, cheats death indefinitely. But here's the cosmic irony. By embracing our finitude, we unlock our most enduring impacts. The artist aware of mortality pours more truth into their work. The scientist racing time makes bolder leaps. A black hole's evaporation isn't failure, it's participation in the universe's grand recycling. Our resistance to entropy isn't about defeating physics. It's about finding grace in the fight, leaving trails of light that outlast our singularities. The universe sprawls across 93 billion light-years, teeming with planets that could cradle life. Yet the silence is deafening. No signals, no artifacts, no cosmic neighbors dropping by. This eerie quiet is the Fermi paradox, the gap between the high probability of alien civilizations and their glaring absence. One unsettling resolution. That intelligent life inevitably hits a wall, a great filter where technological advancement outpaces wisdom, leading to self-destruction. And if that's true for hypothetical aliens, what does it mean for us? Human history reads like a trial run for this very filter. Every breakthrough carries its shadow. Fire warmed our caves but also burned them down. Nuclear power lights cities but once turned 2 of them to ash. The same cognitive gifts that let us cure diseases and compose symphonies also engineer weapons and rationalize ecocide. Death isn't just a biological inevitability, it's a looming specter of our own making, a test we've barely begun to pass. The dinosaurs ruled for 160 million years before an asteroid reset the board. Homo sapiens, a mere 300,000 years old, and already we've brought ecosystems to their knees. But here's where black holes offer an unexpected lens. These cosmic destroyers also sculpt galaxies, their gravity birthing stars even as they consume others. Could mortality serve a similar dual purpose for civilizations? The knowledge that time is limited forces focus. Art thrives under deadlines, societies mobilize against existential threats, and scientific revolutions often spike among aging researchers racing the clock. Without death's pressing horizon, would we have built cathedrals, written constitutions, or launched probes beyond the solar system? The urgency imposed by finitude might be the very engine of transcendence. Yet the counterargument chills. Advanced civilizations could solve aging only to implode from stagnation, their immortal citizens drowning in ennui or fracturing into warring factions over infinite time. Biology's cruel joke is that evolution optimized us for reproduction, not longevity. Our cells accumulate damage, our telomeres fray, not because the universe mandates it, but because natural selection had no reason to craft beings who outlive their reproductive prime. Now, with biotechnology knocking at immortality's door, we face a paradoxical question. Would cheating death save us or remove the last barrier to cosmic irrelevance? The Drake equation, which estimates the number of communicative civilizations, includes a variable for how long such societies last. If the average is short, say, a few centuries post-industrialization, the galaxy might be littered with the ruins of civilizations that flared bright and vanished. Archaeologists dig up collapsed empires on Earth. Might future astrobiologists find similar relics on distant worlds? The ruins of Easter Island stand as a microcosm, a society that felled its last tree to erect statues, unaware it was carving its own epitaph. But there's hope in the outliers. Some species of jellyfish are biologically immortal, reverting to polyps when injured or aged. certain bacteria survive millennia in suspended animation. If life on Earth found workarounds, why not intelligence? Perhaps the filter isn't death itself, but the failure to reconcile ambition with humility. Black holes teach that destruction and creation are entwined. Civilizations that master this balance might endure long enough to leave Fermi's paradox behind. The answer, then, isn't whether mortality is inevitable, it's what we do with the time before it claims us. A black hole's lifespan is written in the stars it consumes and the radiation it leaks. Ours is written in the choices we make before the clock runs out. The silence of the cosmos isn't just a warning, it's a challenge. Will we be another brief flicker, or the civilization that finally answers the call? Black hole mergers are the universe's most violent symphonies, events so cataclysmic they ripple the fabric of spacetime itself. Picture two cosmic titans, each with gravity so strong light cannot escape, locked in a spiraling dance of mutual annihilation. As they draw closer, their immense mass accelerates to nearly the speed of light, churning the surrounding space like a blender until, boom, they collide with a force exceeding all the stars in the observable universe combined. The aftermath, a new, more massive black hole, its event horizon now a blended mosaic of its predecessors, while the energy of the collision radiates outward as gravitational waves. Undulations in spacetime first predicted by Einstein and finally detected in 2015 by LIGO. These waves aren't just scientific curiosities, they're cosmic echoes of transformation, proof that even the darkest entities in existence can create something measurable when they unite. Human relationships follow a startlingly similar arc. Two lives orbit one another, sometimes for years, their emotional gravity pulling them into ever tighter spirals. Conflicts arise, collisions of values, desires, or fears that feel, in the moment, as destructive as any singularity merger. Yet from these clashes often emerges something new, a deeper understanding, a blended family, a creative partnership that couldn't have existed before the impact. Like gravitational waves, the emotional reverberations radiate outward, affecting friends, communities, even future generations. The birth of a child, the founding of a company, the healing of a long-standing rift, these are the human equivalents of that post-collision black hole, singularities of experience forged through friction. The physics of black hole mergers reveals an even deeper parallel, the concept of ring-down. After the initial collision, the newly formed black hole vibrates like a struck bell, its surface oscillating as it settles into equilibrium. These vibrations emit gravitational waves at specific frequencies, allowing scientists to hear the shape of the black hole, much like you'd recognize a bell by its tone. Human transformations have their own ring-down phase, the period of adjustment after a major life change where emotions oscillate between stability and chaos. The raw grief after loss, the disorientation of new love, the growing pains of personal growth, these are the frequencies of our emotional ring-down, the sound of a soul recalibrating. Consider how black holes lose energy during mergers. Up to 5% of their combined mass converts directly into gravitational wave energy, an efficiency unmatched by any known process in the universe. This staggering release mirrors how human conflicts, when channeled constructively, can release immense creative energy. The civil rights movement, born from centuries of oppression, produced art, legislation, and social change that reshaped nations. Personal breakthroughs in therapy often follow intense emotional confrontations. Even in nature, forest fires clear the way for new growth. Destruction and creation aren't opposites, they're partners in a dance older than time. There's a profound lesson in how these cosmic collisions play out across different scales. When two black holes merge in a distant galaxy, The gravitational waves they produce stretch and compress space-time as they pass through Earth, altering the distance between atoms in LIGO detectors by less than 1,000th the width of a proton. Yet we detect them. Similarly, the mergers in our personal lives, the arguments, the reconciliations, the quiet moments of connection, send out ripples too subtle to measure but no less real. A single kindness might bend someone's life trajectory in ways that echo for decades. The universe, it seems, runs on these invisible threads of influence, whether woven by colliding singularities or intertwined human stories. Perhaps most strikingly, black hole mergers demonstrate that isolation isn't the natural state of the cosmos. Left undisturbed, black holes might sit quietly for eons, their immense power latent. But bring them together, and they unleash energies that literally shake the universe. People, too, contain dormant potentials that only awaken through connection, through the creative friction of ideas, the warmth of shared vulnerability, or even the clarifying fire of conflict. The silence of unmerged black holes mirrors the unfulfilled possibilities of unlived lives, while their collisions remind us that transformation often requires the courage to collide. Legacy isn't just about what we leave behind, it's about how what we leave transforms the world. Think of Vincent van Gogh, who sold only a handful of paintings in his lifetime yet posthumously reshaped art history. Or Rosalind Franklin, whose X-ray diffraction images of DNA were critical to uncovering its double helix structure, though her contributions went unrecognized for decades. These aren't just stories of posthumous recognition, they're proof that human energy, like Hawking radiation, lingers long after its source has vanished. A black hole's influence isn't contained by its event horizon. It ripples outward in gravitational waves and scattered particles. Similarly, the ideas we spark, the kindness we sow, even the mistakes we make, radiate into the future in ways we can't always predict. Consider how a single scientific paper can alter the trajectory of research centuries later. When James Clerk Maxwell formulated his equations of electromagnetism in the 1800s, he couldn't have imagined they'd underpin everything from radio to smartphones. Knowledge operates like cosmic background radiation, an afterglow of human thought that permeates the intellectual universe, subtly shaping what comes next. The same principle applies to personal legacies. A grandparent's folk remedy passed down through generations might inspire a biotech breakthrough. A teacher's offhand comment could redirect a student's life like light bent around a gravitational lens. We're all emitting invisible Hawking radiation of influence, our actions rippling through time whether we notice or not. Art makes this process visceral. Beethoven composed his Ninth Symphony while profoundly deaf, channeling vibrations he could no longer hear into a masterpiece that still electrifies audiences 2 centuries later. The symphony's Ode to Joy has been adapted into protest anthems, space mission soundtracks, and global unity hymns, its energy continually reconfigured like particles escaping a black hole's pull. Creative works are thermodynamic miracles, pockets of negative entropy where chaos is briefly held at bay. A novel written in solitude, a graffiti tag on a subway car, even a viral social media post, all resist dispersion, imprinting order onto the universe's relentless slide toward disorder. But legacy isn't always triumphant. Just as some black holes emit only faint Hawking radiation before fading away, many human lives leave barely detectable traces. The ancient library of Alexandria burned, taking countless scrolls into oblivion. Indigenous oral histories were erased by colonization, yet even in loss there's a thermodynamic echo. The absence of those stories shaped what followed, like the ghostly imprint of a star swallowed by a black hole, its gravity still tugging at surrounding stars. Historians call this silent evidence, the gaps where something once was, invisibly steering the present. Your undocumented acts of courage, the ideas you never shared, the love you hesitated to express, these too carve absences that ripple forward. The most haunting parallel lies in quantum information theory. Physicists debate whether data swallowed by black holes is truly lost or merely scrambled beyond recognition. Human legacy faces the same uncertainty. Diaries crumble, languages go extinct, digital files corrupt. But like quantum fluctuations at an event horizon, fragments persist in unexpected forms. A wartime letter found in an attic, a family recipe surviving on a stained index card, a melody whistled absent-mindedly and remembered decades later. These are the Hawking radiation of personal history, flickering signals from beyond the horizon of forgetting. Perhaps this is why we build monuments, write wills, and whisper secrets to grandchildren, not from vanity but from thermodynamic instinct, an urge to slow the dispersal of our energy into the void. The ancient Egyptians entombed artifacts for the afterlife, while today we upload lives to cloud servers. The methods change, the impulse doesn't. Black holes, in their relentless decay, remind us that permanence is an illusion. But transformation, that's the universe's oldest trick. Your body will return to stardust, your name may fade from memory, but the energy you've added to the cosmos, the laughter, the discoveries, the comfort you gave, can no more be erased than the particles streaming from a dying singularity. They're already out there, bending someone's world in ways you'll never see, and that's enough. Quantum suicide twists mortality into a cosmic game of chance with endlessly splitting possibilities. Imagine a modified version of Schrödinger's famous cat experiment, only this time you're the cat. A gun is rigged to a quantum particle's random decay. If the particle decays, the gun fires. If it doesn't, you survive. In a single universe, the odds seem grim eventually. The gun will fire. But in the multiverse interpretation of quantum mechanics, every possible outcome spawns a new reality. In one branch you die, in another the particle doesn't decay and you live to play again. From your subjective perspective, you'd only ever experience the timelines where survival defies the odds, creating the illusion of immortality. It's like flipping a coin eternally, and only ever seeing the heads up results a cosmic sleight of hand where consciousness sidesteps death by riding the branching paths of reality. This thought experiment, first proposed by physicist Max Tegmark, isn't a recipe for eternal life. It's a lens to examine how deeply mortality is tied to our understanding of reality. Black holes already shattered classical physics by showing that information isn't destroyed, just transformed. Quantum suicide takes it further, suggesting that subjective experience might not end even when the body does. The parallels are unsettling. Just as matter crossing a black hole's event horizon appears frozen to outside observers while continuing normally for the traveler, quantum suicide implies that death might be a threshold only visible from the outside. To the conscious observer, the game never ends. Critics pounce on the experiment's flaws. For one, it relies on the controversial many worlds interpretation of quantum mechanics, which remains untestable. There's no evidence consciousness chooses branches, and the idea smacks of solipsism, the belief that only one's mind is sure to exist. Worse, it implies a bizarre narcissism of the universe, where your awareness somehow gets special treatment over trillions of other versions that perish. But the real sting lies in its emotional sterility. Even if true, the you that survives isn't the you reading this now. Memories, relationships, continuity, all fracture with each branching point, leaving something more akin to a copy than a continuation. Yet the thought experiment holds value beyond literalism. It forces us to confront how poorly we grasp consciousness itself. Black holes taught us that space and time are fluid. Quantum suicide suggests the same might apply to identity. If every decision spawns new universes, then death isn't an absolute end but a divergence, a path your awareness no longer follows. This isn't about cheating mortality, it's about redefining it. The heat death of the universe, black hole evaporation, even the decay of your body, all might be local phenomena in a grander multiverse where existence constantly forks. The most profound takeaway isn't immortality, but humility. Physics keeps revealing reality as stranger than fiction, where singularities bend rules and quantum particles ghost through walls. If even death isn't the fixed horizon we assumed, what other certainties might crumble? Black holes once seemed like mathematical oddities until we found them lurking in every galaxy. Perhaps the real lesson is that the universe enjoys subverting expectations, and our finite minds are just beginning to trace the edges of its infinite game. Black holes haunt our stories like cosmic ghosts, both feared and revered. In Christopher Nolan's Interstellar, the black hole gargantua isn't just a plot device. It's a literal and metaphorical gateway, bending time to reunite a father with his daughter across the decades. The film taps into something primal, the idea that these celestial monsters might hold keys to redemption, bending the rigid laws of mortality to allow one last connection. Contrast that with Event Horizon, where a black hole becomes hell itself, a Lovecraftian nightmare spewing forth unspeakable horrors. These polar portrayals reveal our cultural schizophrenia, black holes as both destroyers and deliverers, embodying our deepest dread of the void while teasing the possibility of transcendence. Literature weaves similar dualities. In A Wrinkle in Time, Madeleine L'Engle's tesseract unfolds in space-time functions like a benign black hole, whisking characters across dimensions to confront cosmic evil. It's a child-friendly metaphor for facing the unknown, where the abyss becomes a classroom rather than a coffin. Meanwhile, sci-fi legends like Arthur C. Clarke and Larry Niven imagine black holes as evolutionary crucibles. In the Songs of Distant Earth, humanity uses them as slingshots to escape a dying Earth, turning cosmic terror into a tool of survival. The message is clear: confronting annihilation sparks ingenuity, whether in fiction or the real-world physics labs studying Hawking radiation. Even music channels this tension. David Bowie's Black Star album, released days before his death, transforms a collapsing star into a symbol of artistic rebirth. The title track's eerie refrain, "Something happened on the day he died," suggests a singularity where identity dissolves into legacy, much like matter compressed into pure energy. Hip-hop collective Clipping takes it darker with Story 2, where a black hole's gravity becomes an allegory for addiction's inescapable pull. Across genres, artists graft existential questions onto cosmic phenomena, turning astrophysics into emotional shorthand. Video games push the metaphor interactively. Outer Wilds tasks players with unraveling a solar system's mysteries before a supernova resets the clock, weaving black holes into a meditation on acceptance and cyclical time. Die and you wake again by the campfire, memories intact but progress erased. A digital reincarnation loop. Meanwhile, Destiny 2, the Taken King expansion, frames black holes as corrupting forces, their event horizons birthing monstrous paracausal entities. These narratives reflect our fractured relationship with mortality, sometimes a puzzle to solve, other times a monster to outrun. The pattern is unmistakable. Whether in film, music, or gaming, black holes serve as Rorschach blots for human anxiety and hope. They're the ultimate blank canvas, scientifically enigmatic enough to project our fears of erasure, yet mathematically structured enough to suggest hidden order. When Doctor Who visualizes a TARDIS plunging into a black hole as a descent into a cosmic junkyard, or when Ad Astra uses one as a backdrop for paternal reconciliation, they're not just exploiting cool visuals. They're wrestling with the same paradox black hole thermodynamics presents, that endings might be illusions masking transformations we don't yet understand. This cultural obsession isn't escapism, it's rehearsal. By staging mortality plays with black holes as stand-ins, we inoculate ourselves against the terror of impermanence. The alien becomes familiar, the infinite feels navigable, and the abyss, however briefly, stares back with something resembling meaning. Black holes don't just bend space-time, they expose the frayed edges of human comprehension. Picture a team of astrophysicists huddled over supercomputer simulations, equations scrolling faster than the eye can follow. They're mapping a singularity, but the math keeps breaking down. At a certain point, their variables dissolve into infinities, their models collapsing like stars under their own gravity. It's not a failure of intellect, it's the universe enforcing a boundary. Some doors simply won't open, no matter how hard we push. This humbling reality mirrors our confrontation with mortality. Medical science can dissect cells down to their quantum vibrations, yet consciousness, the shimmering eye behind your eyes, slips through the scalpel's edge. We can chart a dying brain's electrical storms, but where does the light of awareness go when the storm ends? Both frontiers, the singularity's core and the self's extinction, share a maddening trait. They're observable up to a threshold, beyond which they become mirrors reflecting our limitations back at us. History brims with examples of this epistemic surrender. In the 1600s, Newton's laws tamed planetary motion, but hit a wall with gravity's spooky action at a distance, a puzzle Einstein later cracked, only to balk at quantum randomness. Today, Hawking radiation lets us peer closer to black holes' edges, but the equations still crumble at the singularity. Each breakthrough doesn't erase the unknown. It redraws the border further out, like explorers realizing their map's edge was just the shore of a vaster ocean. The parallels to human finitude are poignant. Paleontologists can reconstruct a T-Rex's skeleton down to its marrow, but the creature's roar is lost forever. Archaeologists uncover Sumerian tablets but may never grasp how their writers truly felt watching the same stars we do. This isn't just about incomplete data, it's about the irrevocable silencing that time imposes. Black holes, in their way, enforce a similar silence. Matter falls in, information scrambles, the universe keeps its secrets, yet there's a peculiar grace in this surrender. The recognition that some answers lie beyond reach isn't defeat. It's an invitation to reframe the questions. When the poet John Keats wrote of negative capability, he praised the artist's comfort with uncertainty, the ability to dwell in mysteries without any irritable reaching after fact. Modern cosmology embodies this spirit. Scientists now speak of the cosmic horizon, the limit beyond which light from distant galaxies will never reach us due to the universe's expansion. Some truths, it seems, are cosmically censored. This boundary isn't passive, it actively shapes understanding. Just as Heisenberg's uncertainty principle states that measuring a particle's position blurs its momentum, our tools for probing black holes alter what we seek. Telescopes catch X-rays from accretion disks but can't see past the event horizon. MRI machines map dying brains but can't capture the moment awareness winks out. The act of observation, whether of collapsing stars or fading heartbeats, is always a negotiation with the unknown. Perhaps the deepest lesson lies in how we navigate this frontier. Some cultures, like the Taoists, embrace the ineffable with concepts like the nameless, the reality that predates language. Indigenous Australian songlines treat knowledge as a living, evolving thing, not a static set of facts. Black holes, in their inscrutability, remind us that wonder and ignorance aren't opposites, they're partners. The moment we stop pretending to have all the answers is the moment we truly begin to see. So while telescopes grow sharper and microscopes delve deeper, some shadows will always linger at the edge of understanding, not as failures, but as reminders that the universe owes us no explanations, and that mystery, in the end, is what keeps the stars alight in our eyes. Biocentrism flips the script on everything we assume about reality. Instead of life being a random accident in a pre-existing universe, this radical theory suggests consciousness might be the very fabric holding existence together. Think of it like a cosmic version of the observer effect in quantum mechanics, where particles don't settle into definite states until measured. But here, the stakes are infinitely higher. What if the universe only takes shape because life emerges to perceive it? This isn't just philosophy, it's a hypothesis with startling implications for mortality. If consciousness creates reality, then death might not erase you. It could simply rearrange your role in the continuum of observation. The roots of this idea stretch back further than you'd expect. Ancient Vedic texts describe the universe as a dream of Brahman, while 18th century philosopher George Berkeley argued that reality persists only through divine perception. But modern biocentrism, championed by scientist Robert Lanza, grafts these concepts onto cutting-edge physics. His work suggests that space and time aren't external absolutes but tools our minds use to process experience, like a VR headset we can't take off. In this view, dying isn't exiting the universe, it's shedding one perceptual framework for another. Imagine a fish believing water is nothingness until it breaches the surface and discovers a new dimension of reality. Could death be a similar threshold? Quantum mechanics fuels this speculation. The double-slit experiment shows particles behaving as waves until observed, as if reality waits for a conscious audience before deciding what to perform. Some interpretations, like von Neumann-Wigner consciousness theory, go further, proposing that awareness itself causes the collapse of quantum possibilities into solid events. If true, the universe without observers would be a fog of probabilities, a symphony without ears to hear it. This leads to a staggering corollary. Life and cosmos might be codependent, like dancers who only exist because they move together. Critics pounce on the gaps. If consciousness creates reality, why do galaxies billions of light years away, places no human could ever witness, obey the same physics as our backyard? Biocentrism counters with the anthropic principle. We see a universe compatible with life because, well, here we are observing it. The rest might be like unloaded chunks in a video game, potentially infinite, but only rendered in detail where players roam. It's a dizzying thought. The Big Bang wasn't the start of everything, just the start of our observational horizon. Now apply this to mortality. If consciousness is foundational, not emergent, then death might be less like a candle snuffing out and more like a camera switching lenses. Near-death experiences, with their tunnels of light and life reviews, could be glimpses of this transition, moments when the brain's filters falter and broader perception leaks through. Even black holes, those cosmic erasers, might play a role. Their event horizons could be perceptual boundaries, zones where one mode of observation gives way to another. After all, if information isn't destroyed but transformed, why assume awareness is any different? The implications ripple outward. If biocentrism holds, grieving someone's death might be like mourning a character who steps offstage while forgetting the actor still exists. Cultures that practice ancestor veneration or believe in reincarnation might have intuited this all along. Even entanglement gets a fresh spin. If particles stay connected across space, could minds maintain latent links beyond bodily limits? The theory doesn't promise immortality, but it reframes life as something more like a focal point in an infinite field of consciousness, a temporary localization of something far vaster. Of course, this dances on the edge of science and metaphysics, but that's where black holes once lurked before we photographed one. Maybe death, like those dark giants, isn't an end, just a distortion in perception spacetime, bending what we think we know into shapes waiting to be decoded. After all, if the universe truly needs life to exist, then oblivion isn't just unlikely, it's logically impossible. You're not a guest in this cosmos. You're its co-author, writing each moment into being with every breath and blink. Black holes don't bargain, they don't negotiate, they simply are relentless reminders that some forces in the universe operate beyond our control. Yet within their inevitability lies an unexpected gift, a blueprint for how to live. If these cosmic behemoths can radiate light even as they fade, what does that say about our own fleeting existence? The first lesson is acceptance. A black hole doesn't rage against its evaporation. It participates in the universe's grand recycling with a kind of stoic grace. Astronomers observing ancient quasars see this play out over eons, active black holes blazing with energy before quieting into dim remnants, their arcs mirroring human lives in miniature. The serenity isn't resignation, it's recognition that fighting physics is as futile as shouting into the void. Curiosity is the second offering. Consider how scientists responded when Hawking's equations suggested black holes shouldn't glow. They didn't dismiss the math, they leaned in. That intellectual courage reshaped astrophysics. Mortality, too, becomes less terrifying when met with questions rather than dread. What if dying isn't an end but a transformation we lack the language to describe? Indigenous cultures from the Maori to the Lakota have long framed death as a change of state, like water becoming vapor. Modern physics echoes this. Energy never disappears, it just rearranges. The carbon in your bones will one day fuel supernovas in distant galaxies. You're not a temporary visitor in the universe, you're its permanent material, endlessly repurposed. Then there's awe, standing at the edge of understanding, whether peering into a telescope or a hospice window, triggers the same visceral humbling. The Hubble images of black holes shredding stars aren't just data, they're cosmic vanitas paintings, memento mori written in plasma. But awe doesn't paralyze, it electrifies. Studies show that people who regularly experience wonder exhibit greater generosity, creativity, and resilience. It's as if confronting vastness shrinks petty grievances to scale. The terminally ill often report this shift, vividly trivial worries falling away while ordinary moments glow with newfound intensity. A sunset isn't just a sunset when you're acutely aware of how few you'll witness. The final lesson is legacy. Black holes teach that influence outlasts form. A singularity may vanish, but its gravitational waves ripple through spacetime for eternity. Your actions operate similarly. The Dutch artist Hieronymus Bosch died in 1516, yet his surreal visions still shape modern art, psychology, even video game design. A grandmother's recipe passed down through generations alters family gatherings centuries later. These aren't metaphors, they're thermodynamic facts. Energy disperses but never dissipates. Every kindness, every breakthrough, every moment of courage becomes part of the universe's permanent record, etched into causality's fabric like information on an event horizon. So here's the paradox. Embracing mortality isn't about counting down days, it's about expanding them. The astronomer Carl Sagan, reflecting on the pale blue dot image, noted how realizing our insignificance in the cosmos actually deepens our responsibility to deal more kindly with one another. Black holes, those ultimate symbols of oblivion, oddly nudge us toward the same insight. Their indifference isn't a threat, it's a liberation. If nothing lasts, then what matters isn't permanence but quality. The heat of your connections, the light of your curiosity, the gravity of your impact. The universe will forget your name, but never your atoms or the ripples you left in the space-time of human experience. As we stand at the edge of this cosmic exploration, staring into the abyss where black hole thermodynamics and human mortality intertwine, a profound symmetry reveals itself. The same laws that govern collapsing stars also pulse through your veins, entropy shaping your cells as it shapes galaxies, time bending your memories as it bends space-time near a singularity. This isn't poetic coincidence, it's the universe whispering a fundamental truth. Existence trades in transformation, not permanence. Black holes teach us that even the most destructive forces participate in creation, their evaporation seeding future possibilities. Your life, too, radiates influence far beyond its visible horizon, not through defiance of physics, but through collaboration with it. Consider the humble photon. A particle of light swallowed by a black hole isn't erased, it's imprinted on the event horizon like a fingerprint, its energy later re-emitted as Hawking radiation. Human legacy operates similarly. The ideas you share, the love you nurture, the justice you champion, these aren't erased by time. They're encoded in the fabric of culture, resonating in ways you'll never witness. Just as astronomers reconstruct galactic histories from scattered starlight, future generations will piece together stories from the traces you leave behind. The Maya built temples aligned with Venus. Your digital footprint might one day be someone's Rosetta Stone. This perspective shifts mortality from a countdown to an invitation. If a black hole can blaze with radiation as it fades, why shouldn't your finite years burn brighter? The artist Frida Kahlo turned chronic pain into vibrant canvases. Stephen Hawking's paralyzed body-birth theories that reshaped cosmology. Their limitations became lenses focusing extraordinary light, a proof that constraints don't diminish meaning, they concentrate it. Your mortality isn't a flaw in the universe's design. It's the very mechanism that makes your choices matter. Yet wonder remains. The holographic principle suggests reality might be a projection from some distant boundary, with black holes as cosmic archivists. Could human consciousness play a similar role, not just observing the universe, but participating in its very structure? We don't know, and that's the exhilarating part. Science at its best doesn't eliminate mystery, it frames the questions more beautifully. Each answer unveils new enigmas, like peeling an infinite onion where every layer reveals deeper patterns. So let's close not with conclusions but with open hands. The universe doesn't owe us immortality, but it gifts us something rarer, the chance to be part of its unfolding story. Your atoms were forged in stellar furnaces, your mind shaped by billions of years of evolution, and now, for this fleeting moment, you get to witness it all. That's the real revelation. Black holes and human lives aren't just subject to the same laws. They're collaborators in the same magnificent, mysterious dance. Press subscribe if you want to keep exploring the cosmos and each other, with curiosity as your compass. The next revelation is always just beyond the horizon.